In this lesson, we're going to discuss the mean or the expected value and the standard deviation of a probability distribution. We want to think about the mean of a random variable and what you would expect to happen over thousands of trials. This is what's known as the expected value. So you want to look at the expected value as the long-term mean or average. Now, the way that you calculate the expected value is listed here. Here's the notation for expected value. We use function notation with a capital E. And then also, this is how we're going to calculate it. The X represents the value of the variable, and the P of X is the corresponding probability. So what we would do is we take the value of the variable, multiply it by the corresponding probability, and we do that for each value of the variable. And then we see this symbol here, the sigma notation, that tells me that after we find all those products, we want to add them up. So that's our formula. Let me make a little arrow here, and then that notation means to sum or add up all the values. Okay, so that's our formula to find the expected value, and that's going to make a lot more sense once we actually go through an example. Now, for the law of large numbers, this basically tells us as the number of our experiments or our trials increase, the actual probability that we're getting in those trials is going to get closer and closer and closer to the theoretical probability. So, for example, if I flipped a coin 4 times, theoretically, I know that I should get a probability of heads half the time and tails the other half. So I should have a probability of 50%. Now that's theoretically, but when I actually perform the experiments, maybe I get a tail 3 of the 4 times. So that would give me a probability of 75% that I would get tails. But we know in our heart and in our gut that it should be 50%. That's the theoretical. That's what we expect it to be. So the more and more experiments that I complete, the closer and closer that 75 is going to get to actually approach that theoretical probability of 50%. So instead of just performing 4 flips, if I do 100 flips and then 200 flips and then 500 flips, the more experiments I complete, the closer that probability is going to get to 50%. So what I would put down to help you understand the law of large numbers, I would put that as the number of trials or experiments increase, meaning the more that you complete, the closer the actual probability gets closer to the theoretical. Okay, let's actually start walking through some examples now so that you can apply this and see how it works. Okay, in the first example, we have a men's soccer team, and it says a men's soccer team plays soccer 0, 1, or 2 days a week. The probability that they play 0 days is 20%. The probability that they play 1 day a week is 50%, and then the probability that they play 2 days a week is 30%. Find the long-term average or expected value, which is the mean of your probability distribution. We want to find the expected value of the number of days per week that the men's soccer team plays soccer. So we first have to label or describe our variable. So X is our variable, and that is the number of times per week that the soccer team plays. Okay, now in the problem, it says that they either play 1 day or 0 days, 1 day, or 2 days. And then the corresponding probabilities for those values of our variable was 20%, 50%, and 30%. Now this is what we talked about in the last lesson. This is our probability distribution table. Where we list all the values of our variable and the corresponding probabilities. We want to make sure that the probabilities, each of these lie between 0 and 1, and they do. And then we also want to make sure when we add them up that we get 1. So if I take 20%, 50%, and 30%, that adds up to 100% or 1. So that works. So this probability table checks out. Okay, now to find the expected value, remember, we find each of the values of x and we multiply it by the corresponding probability, and then this symbol tells us to add up all those values. So in the last column of our table, I'm going to multiply my value of x with the corresponding probability. So I take 0 times 20% or 0.2, that's going to give me 0. I'm going to take 1 times 0.5, that's going to give me 0.5. And then I'm going to take 2 times 0.3, that's going to give me 0.6. Now when I add up all those values, my expected value is going to be 1.1. So what this means, I would interpret this as the men's soccer team will play an average of 1.1 days per week. And so that's our interpretation. Let's look at the next example. Find the expected value of the number of times a newborn baby's crying wakes his mother after midnight. The expected value is the expected number of times per week a newborn baby's crying wakes his mother after midnight. We're going to also calculate the standard deviation. Now, I'm going to walk you through how to do all this by hand, but then after that, I'm going to actually show you how you can do this all on the calculator to save yourself the work and the arithmetic. But I definitely wanted to go through this a couple times with you so you can see where the numbers come from. We have, now this was from a previous example in the last lesson. We had our variables was either 0 through 5. I should have added that in here. Let me put that in here. X's take on the value of 0 through 5 days, or I should say nights. The probability was given to us in the previous example as well. So let me write that down. So we have 2 out of 50, we have 11 out of 50, we have 23 out of 50, we have 9 out of 50, 4 out of 50, 1 out of 50. So let me be clear just to make sure that you don't think you're missing anything. This was actually given in a previous example. And so I'm just kind of recopying it down from that. So you didn't miss anything. Don't worry about that. But now this is where we need to pick up and start making our calculations. So if we want to find the expected value, we need to take each of our values of the variable and multiply it by the corresponding probabilities. So when I take 0 times 250, that gives me 0. When I take 1 times 11 over 50, that gives me 11 over 50. When I take 2 times 23 over 50, that gives me 46 out of 50. I take 3 times 9 out of 50, that gives me 27 out of 50. 4 times 4 out of 50 is 16 out of 50. And then the last one is 5 times 1 over 50, which is 5 out of 50. Now, to find the expected value, we want to find the sum of all of those values. Remember, that's what this symbol tells us to do. So I'm going to add all of those up. 11 over 50, 46 over 50, etc. And then when I add all that up, I get 105 over 50. And we can put that in decimal form as 2.1. So what this means is, if I were to interpret this, is that, so to interpret that, I would say that we would expect a newborn baby to wake the mom up after midnight an average of 2.1 nights per week. So that's how I would interpret that. Now, to find the standard deviation, and I'm only going to go through this once with you by hand, and then after that, we're going to use the calculator for this. What you want to do is you want to take the mean, and in this case, we found that the mean for this probability distribution was 2.1. You want to take the mean and subtract it from your data value, square it, and then multiply it by the corresponding probability. So that's this formula here. Then after you do that, you're going to add all those values up and take the square root. So let's do this step first, and then I'll write off to the side. Then we add them up and square root. That's what we would do next. Okay, so when I take 0, that's my value of my variable, looking at the first row, 0 minus 2.1, then I square that value, and then I multiply it by the corresponding probability, which would be 2 over 50. You would get 0.1764. For the second row, I would take the value of x, which is 1, subtract my mean, which is 2.1, find that difference and square it, and then multiply it by 11 over 50. When you do that, you should get 0.2662. Okay, I'm just going to go ahead through then, since you've seen how to do the first couple, I'm going to go through and write the answers for the next few. Go ahead while I'm writing down the answers, if you would like, to go through and double check them yourself to get an idea of how this works. Then we would add all of these up. Once we do that, we would get a total of 1.05, and then we square root 1.05, and that's going to give us our standard deviation that we calculated by hand. And if we round it to 4 decimal places, that gives us 1.0247. So here's our standard deviation that we calculated by hand. And then here's our mean, or our expected value, for our probability distribution. All right, so on your calculator, what you're going to do is you're going to go into your area where we have your lists. So we're going to hit the Stat button, and we're going to choose option number 1, Edit. Now, I already have a bunch of stuff in there, so I'm going to delete my list 1 and list 2. If you forget how to do that, you want to highlight the name of your list, L1 or L2, and then you're going to hit Clear, Enter, and that will clear out your list of anything that you have in there previously. Now for this, you're going to need 2 lists, because we're basically going to set up our distribution table in list 1 and list 2. In the first list, we are going to put our values for x. So using this example that we just did, I'm going to put in there 0 through 5. So here are my values for my x's, right? Those are my variables. Those are the values that my variables take on. Then in the second list, we are going to put the corresponding probabilities. So I'm going to put in the corresponding probability for 0 is 2 out of 50. And then we're going to do 11 out of 50. And then 23 out of 50. And then 9 out of 50. And 4 out of 50. And then the last one is 1 out of 50. So in the first list, I have my values of x, and then in my second list, I have the corresponding probabilities. Now you want to make sure that these are paired up correctly or else this isn't going to work. You can't just mix and match. You have to make sure, for example, that 1 is paired with the probability of 11 out of 50, which is 0.22. So these have to be paired up correctly for this to work. Okay, once you have your distribution table set up in here, then what you're going to do is you're going to hit the stat button, and we're going to go over to calculate. And what we're going to do is we're going to calculate the one variable stacks like we normally do. However, instead of leaving the frequency distribution blank, we're going to let the calculator know that this is a probability distribution table. So your list, what I'm going to put in the list is the values, or the list that I put my variables in. So I put my variables in list 1. So I want to make sure that where it says list, it says list 1. Under frequency list, this is where I want to tell the calculator where my probabilities are listed. I put my corresponding probabilities in list 2. So I'm going to make sure that that says list 2. Then you're going to choose calculate. Now, if you have the other model of the calculator where when you hit one variable stacks, it comes up on your home screen, you want to put in your X list. So for me, I would put in L1 and then hit the comma button, and then you put the list where you put your probabilities. So you want to do one variable stacks on your home screen, then the first list, comma, the second list. Now, when I look at this, the very first option up here will have my expected value, my mean. And we calculated that by hand and we got 2.1. So that works. We did this correctly. Now the standard deviation for our probability distribution is right here. That's this. And when we did that by hand and we rounded it to 4 places, we got 1.0247, I believe, which works because the calculator goes out a little bit further, but when we rounded, we had this bumped up to a 7. So in this next example, it's talking about playing some kind of a lottery. It says, suppose you play a game of chance in which 5 numbers are chosen from 0 to 9. A computer will randomly select 5 numbers from 0 to 9 with replacement, meaning your numbers could repeat. You have to pay $2 to play, and if you win, you could profit $100,000, and you have to match all 5 numbers in order to do that. Over the long term, what is your expected profit of playing the game? We're not given the probabilities for this one, but we have enough information to figure it out. If we lose, we're only going to lose the $2 that we played into the game, but if we win, we could get a profit of $100,000. Now, we're not given the probabilities in this example, but we have enough information to figure it out. We're going to use the multiplication rule here. We have to pick a 5-digit number. And for each spot, because we're doing with replacement, for each spot, there's 10 possibilities for each of those. And so I have a 1 in 10 chance of picking the number for the first spot, a 1 in 10 chance for the second, 1 in 10 chance for the third, etc., all the way to spot number 5. Using the multiplication rule, I would just multiply each of these probabilities, and I would get 1 over 10 to the 5th, which is 0.00001. Okay, so this is the chance of us winning if we guess all of those numbers right. So I'm going to put that here, 0.00001. Now, the chance of us losing is the complement of that. So if I have a 0.00001 chance of winning, then if I subtract that from 1, there is a 0.99999 chance that we're going to lose. So I'm going to put that here for this probability. Now, I have to, in order to find the expected value, multiply the values of my variable with the corresponding probabilities. So if I take -2 times 0.99999, that's going to give me a -1.9998. And then if I take 100,000 times 0.00001, that's going to give me 1. So now what I need to do to find my expected value, I need to add up my products of each of the values times their corresponding probabilities. And when we add those up, I get a -0.99998. I feel like I missed a 9 somewhere. Let me double check. Yeah, I did. Right here. This should be 4 9s and 8. Now I would interpret this by saying, if I notice this is a negative sign, so that indicates that it's going to be a loss. And this value is really, really close to $1. So I would say, on average, if I play this game many, many times over a period of years, over and over again, on average, I would lose $1 each game played. Okay, in this next example, we have, suppose you play a game with a biased coin. For those of you who may not know what that means that the coin has been built in such a way so that there isn't a 50-50% chance of heads and tails. And so you're going to play each game by tossing the coin once. The probability of getting heads is 2/3, and the probability of getting tails is 1/3. If you toss a head, you pay $6, but if you toss a tail, you win 10. So if you play this game many, many times, what will you come out ahead? What's your expected win or loss? Okay, so in the first part, we're going to define the random variable. And just like in the last example, the value of x is going to be your amount of winnings or losings. And then we're going to fill out the table, of course. So you would lose $6, and the probability of that happening, given in the information in the problem, was 2/3. This was our corresponding probability, so I'll write that in the chart. And then for $10, if we win, that's a 1/3 chance in that happening. And so to find the expected value, we are going to find the sum of all of our x's times our corresponding probabilities. So that's what this column is going to be. We're going to find all of our x's times our probabilities. So if I take 10 times 1/3, that gives me 10 over 3. And then if I take 6 times 2/3, that gives me negative 12 thirds. Some of this table was already filled in for us, which is nice. And now I have to add this column to find our expected value. So if I take 10 thirds and I add negative 12 thirds, I'm going to get that our expected value is negative 2 thirds. And then if we put that in decimal value, this is about 0.67. So we're going to lose about 67 cents. Okay, what is the expected value? Do you come out ahead? Well, based on what we just showed here, we would lose, on average, long term, 67 cents, and then that's each time you play. Or you can call it a trial. To find the expected value of our probability distribution, we want to go to the stat menu and go into our list for edit. I'm going to use my list 1 and list 2 again, so I'm going to clear that out. So for our winnings, I would put in L1 10. That's my first value of X. And then for loss, my second value of X, I would put negative 6. Now make sure you don't use the subtraction here. Remember to use the negative key or else you'll get yelled at. Let's see. And then I want to put in my corresponding probabilities, making sure that they line up. For winning, my probability is 1 out of 3. So I'm going to do 1 divided by 3, enter. And then for a loss, for my negative 6 value, I'm going to have a probability of 2 thirds. Now I'm going to hit the stat button and go over to calculate and choose one variable stats. I want to make sure that my list L1 has my X values in it. So if you put your X values in a different list, make sure it shows up here as the appropriate list. And then you want your list where you put your probabilities to be under your frequency list. Mine's already set up. And again, if you have the other model where you hit the button that says one variable stacks and it brings you back to your home screen, you want to do first list, comma, and then whatever your second list is. I'm going to hit enter, and then it's going to tell me what my expected value is. That's this, my mean up here. And it's a negative, so that tells me it's a loss. When we calculated this by hand, I rounded to 2 places because we were talking about dollars and cents. And so I got 0.67. And same thing here, if I round this, this should be 0.67. Now, if we also want to check out the standard deviation for this probability distribution, you can see that the standard deviation is 7.54 if we also round to 2 places. Okay, in this next example, we have that we're going to toss a fair 6-sided die, and we're going to do that twice. Let X be the number of faces that show an even number. We are going to construct a table and calculate the mean and standard deviation. So I have here a table that shows all the possible outcomes when we roll 2 dice. So the way that we want to read this, in case you haven't seen something like this before, is, for example, this value here in the table, the 2, 3, that means on the first die, I roll a 2, and then on the second die, I roll a 3. As compared to this one here, this means on the first die, I roll a 3, and on the second die, I roll a 2. And then maybe just one more example. This means I roll a 4 on the first and a 6 on the second, whereas this one here means I roll a 6 on the first and a 4 on the second. So just so you have an idea of what that table means and how to read it, we want to create a table that shows how many times we get an even number. Since we're rolling the dice twice, we could get an even number 0 times, we could get an even number 1 time, or we could get an even number 2 times. The number of times that we could get 0 even numbers when we roll the dice twice, here is an outcome where we don't get any even numbers. This one here, this one here. So I'm just going through and finding all the places where we do not have any even numbers. Then we have this one, this one. Let's see. So when I count all of those possibilities of where both dice comes out to be odd, not even, that is 9 out of 36 possibilities. Now let's look at the number of times where we would get one even number. That would be here, here, here. So I'm circling all the places where we would have just one even number. All right, now if we count those all up, let's see, that's 18 out of 36 possibilities. Now where we would get two even numbers, let's see all of those values. Let's see, these are even. I'm worried I'm going to miss one because I'm going through this fairly fast. Let's see. I'm going to go through and check again. These all have a 1 in them. These all have a 3. So it's not those. I think that's it. Okay, so when we count all those up, that would be 9 out of 36. In the next column, we need to take the values of x and multiply them by the corresponding probabilities. So when I take 0 times 9 over 36, that gives me 0. When I take 1 times 18 over 36, that gives me 18 over 36. And then when I take 2 times 9 over 36, that gives me 18 over 36. Now, one thing I did actually forget to do, I want to make sure that these add to 1. And when I add them, that gives me 36 over 36. So this checks. You want to make sure that you do that when you create your probability distribution, just to make sure you didn't make any mistakes. All right, now that we have all of our x's times our corresponding probabilities, to find the expected value, we want to add all of those values up. So when I take 18 over 36 plus 18 over 36 plus 0, that's going to give me 36 over 36, which is 1. So we're going to use this as our mean. That's our expected value when we go to calculate the standard deviation in that last column. So when we do it by hand, we're just going to take the difference between each of the x values and the mean that we just calculated, which is 1. We're going to square that difference and then multiply it by the probability. So in each of these rows, I'm going to write down what the answer should be. And then if you want to go ahead and check it, you can. So that's what those values should be for those rows. And then remember what we do to calculate the standard deviation. We add those up and then we take the square root. So when I add those up, I get 9 over 36 plus 9 over 36, which is 18 out of 36. And then when I take the square root, I'm going to get, if I round it to 4 places, 0.7071. So this is our standard deviation for our probability distribution. Okay, so to check our probability distribution, to find our expected value and our standard deviation on the calculator, we're going to go to Edit, and then I'm going to put in my values for my probability distribution table. In my first list, I'm going to put my values of either 0, 1, or 2. And then in my second list, I'm going to put the corresponding probabilities, which would be 9 out of 36, then 18 out of 36, then 9 out of 36 again. Then I'm going to go to my stat button. I'm going to go over to calculate and I'm going to choose one variable stats. I'm going to make sure that my corresponding lister I'm going to make sure that my lists are in there correctly. My first list should be where I put my X values, and then my frequency list should be where I put my probabilities, and then I'm going to go down and hit calculate. My mean or my expected value should be the first entry up here, which is 1, and that's what we got when we did it by hand. And then our standard deviation when we did it by hand, or I should say I put those values in there for you. I'm not sure if you checked them or not, but if you check them, you should get 0.7071. Last example in this section says on May 11, 2013 at 9:30 p.m., the probability that a moderate seismic activity would occur in the next 48 hours in Iran was about 21.42%. Suppose you made a bet that a moderate earthquake will occur in Iran during this period. If you win the bet, you win $50. If you lose, then you have to pay $20. And we're going to let X be the amount of the profit. So we're going to fill out this chart like we did before. If we win, we're going to win $50. So if we lose, we're going to pay $20. And we're going to put a negative in front of that since we don't have that money anymore if we lose. Now the corresponding probability would be that if we win, that would mean that the earthquake happened, and that was a probability of 2.2142. Now, we've got to find the complement of that. If the earthquake does not occur, we would take 1 minus 0.2142, which is 0.7858. Now, to find the expected value to see if we would win or lose overall, then we want to take the value of each of our x's times the corresponding probabilities and then add them up. So we have, let's see, if I take 50 times 0.2142, that's going to give me 10.71. And if I take negative 20 times 0.7858, that's going to give me negative 15.716. So then I have to add up those values. That would give me my expected value. So when I take 10.71 and add negative 15.716, that gives me negative 5.006. So I would interpret this by saying if we made this bet many times, overall, we would lose about $5 per bet. So in this section, we focused a lot on how to analyze these probability distributions, specifically discrete probability distributions. Now, there are several different kinds of probability functions that are discrete, and two big ones that come to mind for me is binomial and Poisson. In this class, we're going to really look into and dig into the binomial